Hello everyone, that is my name. We're going to talk about cache memory, mapping functions, and replacement algorithms. So first we're going to talk about cache memory. Cache memory is designed to combine the memory access time of expensive high-speed memory combined with the large memory size of less expensive low-speed memory. There is a relatively large and slow main memory together with a smaller, faster cache memory. This cache contains a copy of portions of main memory. When the processor attempts to read a word of memory, a check is made to determine if the word is in the cache, and if so, then the word is delivered to the processor, and if the word is not in the cache, a block of main memory consisting of some fixed numbers of words is read into the cache, and then the word is delivered to the processor. We see that the L2 cache is slower and typically larger than the L1 cache, and the L3 cache is typically slower and larger than the L2 cache, which is shown in this diagram. We see that the L3 is larger and typically slower than this one, L2, and also the L2 is larger and typically slower than the what and the L1. We're going to talk about the typical cache organizations, though there are other organizations also in cache memory. This time around, we're going to base on the typical cache organization. The cache connects the processor via data, control, and address lines. The data and the address lines are attached to a system bus from which main memory is reached. When the cache hit occurs, the data and address buffers are disabled and communication is only between the processor and the cache with no system bus traffic. When a cache miss occurs, the desired address is loaded onto the system bus and data is returned through the data buffer, both the cache and the processor. In other organizations, the cache is physically interposed between the processor and the main memory for all data, address, and control lines. In this later case, for a cache miss, the desired word is first read into the cache and then transferred from the cache to the processor. This is how the cache connects to the processor. It connects via the address, the control, and then the data. So we're going to talk about the elements of the cache design. There are so very many elements of cache designs. Among others are listed below. We have the cache address, we have the cache size, we have the mapping functions, we have replacement algorithms, we have write policy, we have line size and number of caches. But here we're going to talk about majorly two, which is the mapping functions and the replacement algorithms. So let's talk about mapping functions. Since there are a few cache lines than main memory blocks, an algorithm is needed for mapping main memory blocks into cache lines. A means is needed for determining which main memory block currently occupies a cache line. The choice of mapping function detects how the cache is organized. So we have different types of mapping functions. So we shall talk about a few the various types of mapping functions, which are also known as the techniques of mapping. We have the direct mapping, associative mapping, and then the set associative mapping. First, we're going to talk about direct mapping. The simplest technique known as direct mapping maps each block of main memory into one possible cache line. We also have associative mapping. This is another type of mapping. We have associative mapping. Associative mapping overcomes the disadvantage of direct mapping by permitting each main memory block to be loaded into any line of the cache. So in this associative mapping, there are no restrictions. Also in this case, each cache typically consists of two parts, that is the tag and the actual data. The tag contains a portion of main address that uniquely identifies which block of data is stored in the slot. And then the data portion holds the content of the block. So we're going to see the advantages of associative mapping. Because since it comes with advantages, so it is flexible. Data can be placed in any cache slot, which reduces the likelihood of cache conflicts and maximizes cache utilization. So sufficient use of cache space blocks can be With use of cache space, blocks can be placed optimally regardless of their memory addresses. Low conflict rates. Since there are no restrictions on block replacement, there is low possibility of multiple memory blocks competing for the same cache slot. Set associative mapping as another type of mapping. This one compromises that it's a compromise that exhibits the strength of both direct and associative approaches with reducing their disadvantages. It's a compromise that exhibits the strength of both the direct and associative approaches while reducing the disadvantages. Here, the cache consists of a number of sets. Each set contains a number of lines. A given block maps to a given line in a given set. For example, 2 lines per set. And then now we're going to talk about another design, which is the replacement algorithms. So we're going to talk about replacement algorithm as part of the cache design. Once the cache has been filled, when a new block is brought into the cache, one of the existing blocks must be replaced. For direct mapping, there is only one possible line for any particular block and one choice is possible. In direct mapping, only one choice is possible. For the associative and set associative mapping, a replacement algorithm is needed. To achieve high speed, an algorithm must be implemented in the hardware. So the replacement algorithm also have like the common replacement algorithms that we use. We have the least recently used, it's also known as the LRU. Most effective, it replaces the block in the set that has been in the cache longest with no reference to it. And then we have the first in, the first out, which is also known as the FIFO. It replaces that block in the set that has been in the cache longest. And then we have the least frequently used, which is also known as the LFU. This one replaces that block in the set that has experienced the fewest references. So with that, I would like to end there. I hope you like the video. Please comment, like, and subscribe for more. I hope to see you next time in the other video. Thank you so much. Have the best of your time as you check on the video. Thank you.